the Z scores.
Okay.
Well, I think if I did it right, I'm pretty sure I did. But then
Okay,
it's
well, why don't,
this.
I'm sorry, it's lagging in audio. I don't mean to interrupt. Go ahead.
Okay, man. But the second part of the question, where it's trying to tell you how to find the unrealistic value for the curve.
Uh-huh.
I've been all over Google, everything, trying to figure out how to do that, and I'm lost.
Okay, well, you're way overthinking it, I bet. But well, this is good. Let's just go over z-scores. In fact, let me just start and explain why we do z-scores. So, with the standard normal curve, and you can jump in anytime, okay?
Okay.
With the standard normal curve, which is like the basic curve where we start out, the mean is always 0, and then the mean 0, and the standard deviation is 1. Okay, so plus 1 over here, plus 2, plus 3, minus 1 standard deviation, minus 2, minus 3. So these are all standard deviations away from the mean. So remember, standard deviation pretty much measures how far you are away from the mean, and which side of the mean you're on also. It does both.
Right.
So why do we need that? Well, we need that because there's so many normal curves out in real life. So if we talk about any normal curve, of course, the mean's not 0. But what we do is we use the z-score. So the z-score takes us any normal curve back to the standard normal curve. So we can compare any normal curve if we take each one back to the standard. Because if, say we're here on a normal curve, and we don't know exactly where that is, then we can compare it. If we take it back to here, then we could say, oh, we're about 2.1 standard deviations from the mean, and then that has some meaning for us because we can do that for any normal curve. So let me just do an example. Let's say, and let's say we have a mean, and it's normal, a mean of, say, 20 and a standard deviation of 2. So we know that, and we know it's normal. So you can always draw your normal curve. The mean's 20. If you go plus 1 standard deviation, that means you add 2. So this would be 22 at plus 1 SD. Add 2 more, you'd be at 24. So you'd be at 2 SD, and add 1 more standard deviation plus 3 would be at 26. And then going this way, you would subtract 2, or subtract 1, sorry, standard deviation, you'd be at 18. Subtract 2 standard deviations, you'd be at 16. And then, sorry, at minus 3 standard deviations, you'd be at 14. Because our standard deviation is 2, so each time we go to the right or left, we either subtract 2 or add 2. So we want to take this to a standard normal curve, and we do that with the z-score, and the z-score equals your score minus the mean divided by the standard deviation. Okay, so suppose we want to know the z-score for 23. Okay, so what's the z-score for 23? That would equal 23 minus 20 divided by 2. Using our numbers up here, that would be 3 halves, or 1.5. So you see what we did. 23, if you look on this graph, is right here, right between 22 and 24. Well, it's also between 1 and 2 standard deviations. So that's what the z-score does. It told us it was 1.5 standard deviations on the standard normal curve.
Okay, so I guess.
So go ahead.
So the problem I'm looking at, so a normal standard, the standard normal curve is a mean of 0 and
Yes.
a standard deviation of 1, right?
Yes.
So a standard deviation 1, 2, and 3 would be 1, 2, and 3. Would that make, I guess for our problem, if you had a value of 4, would that'd be outside of the standard deviation? That'd be the one that's unrealistic because it's outside of the normal curve.
Very good. And very good. Excellent. And also, let me talk about, remember we talked about the empirical rule? Well, I mean, if you don't, we kind of talked about it last week. If our mean is right in the middle, if it's normal, okay, all these have to be normal, of course. And normal just means bell shape. We have about 68 between -1 and +1 standard deviations. 68% of the scores are. Okay, 68% of the data lies between -1 and +1. And then if we go to -2 and +2, we have 95%. Now the book says 95.44, but we're not going to be, most books just say 68, 95, and 99.7. So we're just going to do the 68, 95 rule. And then between -3, oh, I should have used different color. Let's use blue. -3 and +3 standard deviations, that's 99.7% of the data. So, I mean, could we get a 4 out of that if almost everything's between -3 and 3?
No, right.
No, yeah. So +4 would be way out of that range.
So for our assignment, technically one of them is like 3.33. Would that one also be out then?
You could argue for and against that one.
So technically, for the assignment, we could technically have 2 of them that would be outside the band.
Yes, I wouldn't count that wrong. It could be, you know, that if it's 99.7, that leaves 0.3% chance that it's out there.
Right.
Wait.
I guess I'm probably looking more into it than.
Yeah, yeah, I think you're overthinking. So 3.3 is about right here. So that leaves 0.15% of the data could actually be outside, you know, there. So I mean, it's possible, but you could argue against it also.
Okay.
So the 3.3
I'll probably
is
just leave
pretty
it out.
high. But as long as you understand that, you know, either one would be correct. Both, I mean, if you include both.
Okay, that helped a lot. I've been sitting here racking my brain for like 2 hours on that.
I'm sorry. I'm
fine.
sorry. No, it was just pretty much using the empirical rule, or on the standard normal curve. Like I said, everything almost is between -3 and 3 standard deviations.
Okay. No, after you explained it, it started making a lot more sense.
Okay, so do you know how to find z-scores? I mean, is the formula okay for you?
Yeah,
Okay,
the z-score, finding z-score is really easy for me. It was just trying to figure out what didn't fit, I guess, was confusing.
Okay, so and again, it's really important to know why we use them, because again, we can take any normal curve with any mean, any standard deviation, and translate it to this curve with mean 0 and standard deviation 1. So mean is always in the middle. And that's what the z-score does for us. So suppose, our scores, say our score is over here. We know that over here, we could say that it's about negative, say, 2.5 or so. So this score, when you say negative 2.5 standard deviations, you know where that is on a standard normal curve, but maybe the score was like 70 and you don't know where that is on any, on a normal curve. So it's important to translate it over so that you can actually see where that score lies. That's the idea behind it.
Okay. No, that makes a lot more sense.
Okay, good, good.
I guess the other question I had was, I don't know if you had the assignment up, but was assignment 7 with the grocery store cereal, like 1,000 boxes for the mean
Yeah,
and the
I'll have the assignment right in front of me.
yeah, that question's also run me through a loop because I don't think I'm doing it right. Like I found the z-score for them, but then I guess I don't
Okay,
know how
that's
to.
right.
I guess I'm not really. Well, I found it for A and B, but for C, I don't have no idea what I'm doing. But for A and
Okay.
B, I found the z-score, but I don't know how to apply them to get the number that I need at the
Okay,
end, I
I'm going to
guess.
show you two ways. The way I do it, you don't need the z-score. The way the book does it, you use a table. And my my thoughts on all this is that, when you're actually doing statistics and need the numbers, you're not going to have a table in front of you. So I
Right.
always, and the calculators are all online. All the technology you need are online. So I'm going to just show you the way I do it. I think it's the easiest to understand instead of trying to, when you use the tables in the book, you don't get an exact answer because your numbers aren't actually in there. You're just getting approximate answers. So this way you're going to get more exact answers. So, and I think it makes a lot more sense. So here's the way I do it. I'm going to go to the calculator and I'll share my screen in a minute. Let me get to it.
Okay. Yeah, because I was been racking my brain on that one. That's probably 2 hours. That one and the other one, where I've been.
I wish you wouldn't do that. You should just call me because this is not.
Well, I knew we had this caliber, this thing, so I wasn't like too worried about it. But I like to try to figure it out so I can kind of learn how to do it.
I get it. I get it. I just All right. Well. Okay. So do you see this calculator?
Yes, I haven't. Is that the one that comes up when you do problem 5? Because I haven't tried that yet.
Yes. Use that
Okay,
for number 5.
yeah, I haven't attempted that problem yet.
Okay. Well, then you'll know how to do number 5 after this.
Perfect.
Because well, let's just talk about number 5. Okay, and what this is. I love this calculator only because notice it says on top normal distribution. And if you go to the side, see in the left-hand menu, I'm scrolling down. Number 8 is normal distribution standard. That's the calculator that you want. Now later on, we might use, I love this calculator, so I use a lot. Later on, we'll use maybe number 6, number 7, inverse t distribution. We'll use inverse normal distribution. We'll use number 12. So, we'll come back to this calculator. But for the normal distribution, that's number 8 over here. And it says normal distribution right on the top. So the reason I like it is here's your picture, here's a bell-shaped curve, and you can see your answer right away. So notice already the mean is 0 and the standard deviation is 1. So
Mm-hmm.
if you read number 5, the first sentence says, if the random variable z has a standard normal distribution. Okay, so right now we're at a standard normal distribution because the mean's 0 and the standard deviation's 1. So we're already there. Okay, so if you want the probability that, say, z is between 0 and 1.5, well, look at all your choices you have. You have above, and that means the area above, the area under the curve. Here's something really important. The area under the curve is probability.
Okay.
So that tail right there, as we're looking at it, is the probability that our z-score is above 1.96. Just as it stands. I didn't type anything in. I'm just showing you what this represents. That little area in that tail, if you notice, it starts a little before 2, 1.96. So that's the z-score. So the probability that your z-score is above 1.96 is 0.025. Your area is your probability.
Okay.
So here in this problem in number 5, I want between. You see it has between two values. I'm just going to clear everything out. You don't have to, but it makes it easier to see. So I want it between 0 and the z-score 1.5, and all you do is press enter and look at your picture. Your picture is 0, which is the mean. Okay, your z-score is 0. That's always the mean. And it goes to 1.5. See, it's between 1 and 2 on the x-axis. So the area that's shaded is your probability, which is 0.4332.
Oh, wow. I've been
That's it.
overcomplicating the whole time.
Yeah, no, I don't overthink this. This is why I love this calculator. It gives you a exacting, pretty exact, better than the tables. And
Yeah. I was getting so confused with the tables.
so you can use this in Connect too, in the Connect homework.
Okay.
All right, so that just tell me what to do on the next one. In number 5B, what's the probability z is bigger than 2?
So you're going to do, let me scroll up there. Z is bigger than 2, so you're going to do, you'll clear out what you have in there and do above 2.
Right, and you don't have to clear out, just choose above 2. I like to clear that only because it's confusing, but you just do above 2. Yes, just make sure, and look at your graph. Your z-score is at 2, and it's the area to the right of 2. So your answer in that case would be 0.0228. This is the probability that your data is above the z-score 2.
So for the next one, if it's z is less than 1.7, you'll just do the below.
Yes.
Okay.
And just make sure your picture matches what you want.
Right.
That's why the picture helps you see. The picture helps you see it better. So again, the probability that your data is above 2 is only 2.28%. In this problem right here, that shaded area is only 2.28% of the data lies over there. That's not very much, but that's what this shows.
Wow, this is much easier. It makes 5 and 6 a lot easier.
Yeah, so tell me, I think you can do number 6 now. So instead of finding the z-scores, what's the easier way to do it?
You just change the mean and the standard deviation on here.
Exactly.
So you change your mean to 1,000, your standard deviation 94, and then for the first one was the 96 boxes or less, or 960 boxes or less, you would put 960 in the below, I believe.
Very good. Yeah, exactly.
Yeah, that makes it a lot easier.
Again, I like this because you have a picture of exactly what you get. So the probability of that happening is 33.5%.
That's a lot easier.
Okay, so let me go back a minute because there's another way to do it, and I'm not too sure anybody wants to do it this way, but it's fine if you do. What you can do for number 6, like you said, change to z-scores. Okay, so find the z-score. I'll just do part A because we already got an answer. For 960, so it'd be 960 minus the mean divided by the standard deviation. And let me get my calculator. Notice it's negative, so be careful your signs. Okay, so that's your z-score. And then you go to the calculator and you use the standard normal curve. Since you've already switched it, you already found the z-score, so we're going to use the standard normal curve. That means mean is 0, standard deviation is 1. Let's see if we get the same answer. So we're going to go, we're going to go back 0, 1. We're on the standard normal curve, and then we want it below. Okay, before I do that, I want you to notice this graph before I change it. Sorry, let me go back. Notice the graph. The z-score, if the mean's 1,000, the z-score is negative because it's to the left. And that's what we got. We should have that same picture if we change it to the z-score. So watch, it's going to be the same. Negative 0.4255. Same answer.
Oh, okay. Wow.
I mean, that one takes a little bit more work, but I don't care which way you do it. I like the easy way, the first way, but I just want you to see that this is going to give you the same answer with the z-scores.
Doing it with the z-score is fine for A and B, but on C, I'd much rather just use that.
Yeah, well, you could change each one to the z-score and then use the between.
Yeah, but it's way easier to do it your way.
Yeah, it's way simpler. But I just want you to see what the z-score is used for. The z-score, again, translates any normal curve to the standard normal curve. So the first way to do it is just plug in the mean and standard deviation. The second way to do that is to go ahead, find the z-scores, and then use the mean 0 and the standard deviation 1, and you get the same answer either way.
Yeah. Oh. So much easier. I'm just like flabbergasted right now. So.
Yeah, I'm trying to make this simpler as possible. Again, the tables are okay, but when you're in your office or whatever trying to figure out statistics, you're not going to be sitting there having these tables. And again, the tables are online. So if the tables are online, so are these calculators. And this is not the only calculator, but I really like it because it has the picture.
No, yeah, I do too. It makes it a lot easier to understand even.
Okay, so is that kind of clearing up some of the questions?
Oh, yeah.
Oh, good, good. Hi, Nikita. If you have questions, just, you can type right on the screen, and or if you have your microphone, you could talk. Oh no, don't apologize. I'm recording all this, so I will post it when we're done. Okay, but do you have any specific questions? Well, if so since you joined late, what we talked about was the first thing was z-scores, and what we use the z-score for. We use the z-score to translate any normal curve to the standard normal curve. The standard normal curve has mean 0 and standard deviation 1. And the reason we want to translate it to the standard normal curve is that we could take any normal curve out there, which are infinite number of normal curves like height, weight, a lot of things in nature are normal curves. We can take, or test scores, and we can compare tests from two different, like biology and chemistry. We can compare using z-scores. So that's why they're so important. And then we can use that normal calculator to get the probability that our data is between or above z-scores, and that area under the normal curve is probability. So when we draw a normal curve and we get this area, that area is the same as probability. Yeah, that's the same thing Robert said. He didn't really understand why things were, why we were doing z-scores, or why, how did this all tie in? Okay, so let me just briefly, and Robert, jump in with questions. I'm just waiting for questions. Again, we can take any normal curve. The reason we're doing this, and we don't know the mean, we don't know, I mean, we know the mean and standard deviation. Sorry, we do know the mean, standard deviation. The mean is always in the middle. And then we use the z-score to translate it to the standard normal curve. So the standard normal curve has 0 mean and standard deviations equal to 1. So just briefly again, suppose your mean is 45, okay, on a test, say it's a quiz, and then your standard deviation is 5, then we can take any score on here. So let's take, say, 53. Okay, let's take 53 and find the z-score for it. So we take our score minus the mean divided by the standard deviation. That's going to be the z-score. I'm going to do that on my calculator. So that's going to be 1.6. So on this standard normal curve, if the mean is 0, 1.6 is about right here. So we can see and look at on this graph, that's about where this score is. But then we could take, say, another curve, say the mean is 60 and the standard deviation is 4, and then we can use the z-score of any score and put it on the standard normal curve, and we'll know where it's situated at. We'll know where that score lies because we standardized it. So that's why we use z-scores, to take everything to the standard normal curve, see where it lies. And then we talked about we talked about the empirical rule. Okay, again, on a standard normal curve where the mean is 0 and we move over +1 standard deviations, +2 standard deviations, +3 standard deviations, and then going this way, it's -1. And again, I'm just approximating it. You can just draw a rough sketch. But using the empirical rule, it says 99.7% is approximately of the data is between, I can't write real good with this, plus or minus 3 standard deviations from the mean, 99.7. And then between -2 and +2 is 95% of the data, and between -1 and 1 is 68% of the data. So when I do the +1, +2, +3, I'm using z-scores, and that's called the empirical rule. So again, the z-score just takes us to this curve. It standardizes everything to the standard normal curve. That's all there is to it. Robert, did you have any other questions?
So I've pretty much almost everything. After we did everything, I just kind of going through the assignment, and I have pretty much everything done now that I know how to use that tool.
Okay, let me ask what you got for. I'm gonna stop. Well, no, go ahead. It doesn't matter because I'm not sure how many. It's still. I'll go over this again, Nikisha. What did you get for number 7?
I used it, and I got 33.2. I was gonna ask if we were able to use that for this because it kind of has like a sample, so I wasn't sure.
Right. So what does the central limit theorem tell us?
So from the reading, where I write down earlier, I did it in my discussion. It was basically the larger sample you have, the closer to the normal distribution it should be.
Okay. The examples of what though?
Oh, a full set of data.
Once you take a sample, what do you find out of that sample?
The mean?
Yes. Yes, you find the mean, and then when you find the mean, okay, so for the central limit theorem, you're doing all these samples, and then you find the mean out of all those samples. So when you graph it, the histogram is gonna, it should do something like this. Not perfect, but the more examples you do, the means of all the examples form a normal curve. Okay.
Right.
So the more you do it, and in the discussion, I tried to show that by taking more and more examples, and it showed
Mm-hmm.
that it made a normal curve. So in my discussion post, it kind of shows that. Now, here's the problem, and the problem, we don't know if it's normal in number 7. It says unknown distribution, so it's not normal. But for the central limit theorem, you don't need it to be normal, but the sample means form a normal curve. So if you read that question, though, what's the last sentence in that question?
Find the probability that the sample mean is between 42 and 50.
Okay, find the probability that the sample mean is between 42 and 50. Okay, so if you read, you have to do a little bit of reading here, but for the central limit theorem, we don't use the standard deviation. We use standard deviation divided by the square root of n.
Okay.
And I have a video, it's kind of beyond the scope of our class. I have a video of where that square root of n comes in. And I mean, I could take time to kind of try to explain it. It has to do with the variance. And, but I think we should just go with it because we're going to go with this for next week too. If you want to look into this more, though, I did post a video about why we divide by the square root of n in the, if I didn't post it yet, I will. I'll put it in a announcement. But for the central limit there, we're using the means. We're using sample means. So we change the standard deviation to be the standard deviation of the square root of n. So when you go to your calculator, you're not going to use standard deviation of 8 in that problem.
We'd use the standard deviation divided by the square root of 30.
Yes. But you can still use the calculator.
You just have to put the different standard deviation in.
Exactly.
So it'd be 8 divided by, so square root.
So the mean will still be 45, but for the standard deviation, you're going to do 8 over square root of 30. And then you're still going to do between 42 and 50.
So it'd be like 1.46 would be your standard deviation you would use.
Yeah. Yeah. So the key word, and you still use that calculator, but the key words in that problem is probability of the sample mean. Sample mean, that should click for you that that's the central limit theorem. That tells you to do that.
Okay.
To use the standard deviation over the square root of n.
Yeah, that makes sense. Now that I explain it, it makes sense. I didn't. Yeah. Everything makes sense after you explain it. I'm not very good at like reading about math and applying the math.
Well, there's a lot of, reading the book is really challenging.
Yeah.
And that's why I tried to, talk about it in the announcement, that first weekly announcement, and try to explain things also in the discussion post. This one, though, you probably had to do a little research for. See, like, what's the difference between like number 6 and number 6? It just says, what's the probability of the weekly demand? There's nothing about sample means in that question. Okay, so, but number 7 says, find the probability the sample means between 42 and 50. Well, when you're finding the probability of sample mean, right away you should think central limit theorem. But it will say those words.
Okay. So pretty much if it's a sample, you're going to be using that.
Sample mean, if you want to find out where the probabilities, if you want to find out where the sample mean is, you use this.
Right. I'm going to
It
put that
will
down in my notes.
say sample mean. It has to have those words.
So that drastically changed my answer by,
Yes.
I don't
Yes.
know.
By probably 60%.
Yes. Well, this collaborate has been very helpful for me.
Okay, good, good, good. Yeah. Like I said, I try to, when I make that video, I try to focus in exactly on what you need to use for this class. I make them specifically for each week. Okay.
I don't have any other questions.
Okay. Okay. Well, thanks for coming on.
Yeah, absolutely. I appreciate all the help. I really do. I was getting
Yeah.
really frustrated. So.
I don't have the connect exercises printed out, but if anybody has a question on that, I can go look them up. I don't have those printed out though. Did you do those already?
Yeah, the connect's already done. I only
Okay.
had the just assignment left.
Okay. Okay.
So
Looks like you're good to go.
thank you.
Okay. Yeah. Thank you for coming.
Absolutely. Have a good one.
Okay. And Nikisha, I'm just going to go over everything again that we talked about just to make sure. Let's just start from the beginning to make sure that you understand, what we're doing. So I'm going to, let's see. Let me look at this assignment. And the week 4 assignments mainly based on the z-scores. The discussion was just using the central limit theorems. So, okay. So again, what I'm going to do is, let's see, just start here. All right, suppose I have a normal curve, any normal curve. And in nature, heights, weights, length of your foot, there's so many things that follow the normal curve. So suppose we have a normal curve and our mean is 90 and our standard deviation is 10. Okay, and okay, we could suppose these are like test scores. So we can draw a normal curve. The mean is always in the middle. Okay, and then you move over by different standard deviations. And then we come down here and we want to standardize it. And the reason we want to do that is because if we take another normal curve and standardize it, then we can compare those two because they're on the same. It's like changing yards to meters or inches to centimeters. We want to get on the same page. Okay, in the standard normal curve, our mean is 0 and our standard deviation is 1. Always. Okay, it's always true. So if we move over by 1 standard deviation, we go +1 to the right, then it's +2, then it's +3. And if we go to the left, it's -1, -2, -3. Okay, we don't really go beyond 3 because if you remember the empirical rule, and I'll write it down again, but the empirical rule says 68% of our data is between -1 and +1. 68% of the data is there. 95% of the data is between -2 and +2 standard deviations around the mean. And then 99.7% of our data is between -3 and +3 standard deviations. So almost all, 99.7% of the data is between -3 and +3 standard deviations. Okay, so, and again, I'll write that down for you, but I wrote it down previously. What we want to do is say, come back up here, and what if our score, we want to know and find some probabilities. What if our score is, say, 75? Where is that in comparison to the standard normal curve? Well, we could say 75 is about right here, but let's check it out. So to check it out, we find a z-score. And the z-score is our score minus the mean divided by the standard deviation. So I'm going to use my calculator. And notice it's negative. And it should be negative because it's on the left. So that's negative 1.5. Well, what does that tell us? That is the negative 1.5 is on the standard normal curve right over here. So I can't draw an arrow, but it's between -2 and -1 standard deviations. So let me erase this and write it smaller. Okay, so this was -2 on a standard normal curve. This was -1. Minus 1.5 is right here. So okay, good. When you can plug the numbers in, well, that's good. But then we have to understand what does it mean when after you plug the numbers in. So right. That's what I'm trying to get at. This formula. Let's see. Another way I can explain it. This formula, the z-score, let's see. I'm trying to fit it in here. So the z-score is your score minus the mean divided by a standard deviation, translates any normal curve. So I could take any normal curve with any mean, any standard deviation, and it translates our scores. So our score was 75. When we found the z-score by using that formula, it took us to the standard curve right here, negative 1.5. So it standardized our answers. Now suppose I don't have that mean, it's different. Suppose I have use the same curve. Suppose I have the mean to be 100 and the standard deviation to be 7. Okay, so now I have this new normal curve where the mean is 100, and so where does, say, the let's make up a score. Let's say our score here is 80, So the z-score would be 80 minus 100 minus the mean divided by the standard deviation. So for this problem, the z-score would be 2.85. So 2.86, let's say, 2.86. So what it did was it took this score from a different normal curve and it put that score right over here. 2.86 is between 2 and 3. So we standardized it, and now we can compare the two. Let's say there are two tests. We can compare those two tests of where they lie, or those two scores where they lie on the standard normal curve, where before we couldn't compare the two. We had two separate normal curves, and one had the z-score of negative 1.5, the other was 2.86. Now we can see that this score of 80 is way above the score of 75 on that other test. How is it? Oh, it's not positive. You're right. I'm sorry. Okay, let me go back. I'm glad you caught that. I am so sorry. Okay. So negative 2.86 is way over here. Okay, so here's the point, though. The point is that this negative 1.5 came from a different test. That came where the mean was 90 and the standard deviation was 5. So that score of 75 ended up here, and this score ended up way down here of 80. And now we can compare those two tests where they lie on the standard normal curve. So you're not going to have to do any of these comparisons, but I'm just showing you what the z-score does. It takes this formula takes any normal curve back down to the standard normal curve. Now, why would you want to do that? Well, the reason you want to do that is you can use the empirical rule. Okay, which says, here's the standard normal curve. 68% of the data is between -1 and +1 standard deviations. -95% of the data is between -2 and +2 standard deviations, and between -3 and +3 standard deviations from the mean. Again, 0 is in the middle. 99.7% of the data, almost all the data, is between -3 and +3 standard deviations from the mean. So if we can take any normal curve and get it on this standard normal curve, we can use the empirical rule. Also, okay, I want to show you that calculator. So let me show you that on a calculator. I'm going to share my screen. So this is the calculator on the assignment. And notice it says normal distribution. It's number 8 on this left-hand side. We're going to use some of these other calculators too, but number 8 is the normal. And the reason I like it is because it has our normal curve picture. Okay, so let's look at this. Our standard normal curve, the mean 0, standard deviation's 1. If we want between -1, the z-score, and +1, the area or the probability of that should be, look, 68%. 0.68 is 68% of our data. The area shaded here is the probability that our data is in that area. So this is showing us that 68% of the data in our list or in our population is between -1 and +1 standard deviations from the mean. This is how it ties in together. Now, if we want between -2 and +2, we said it was 95. So there it is, 95.45. So not about 95%, and that's just an approximation of our data is between -2 and +2 standard deviations of the mean. Again, the area under there is the probability that our data is there. And then if we do -3 and +3, 99.7% probability that our data is there. So there's hardly anything on those tail ends, hardly anything there, hardly any data beyond -3 and +3 standard deviations. So like what we were talking about in number 5, if we want the probability that the z-score is between 0 and 1.5, all we have to do is say the probability the z-score is between 0 and 1.5. Look at our picture. The z-score is right here, 1.5, and it's 43%, or 0.4332. So the probability that our data is between 0 and 1.5, which are z-scores, this is the standard normal curve, is 0.4332. Is that making sense? Yeah, a lot of people, I mean, it's so easy to overthink this, but please don't. We're not using the tables. I told Robert that. We're not using the tables because they only give approximate answers. And with all the technology out today, you know, why not use technology? I love that calculator because it gives us a picture of where things are. So it's even easier, like if we want, let me share this. Let me go back and share it again, the calculator. Yes, you can use it on the homework. You're going to be able to use this on the final, on the homework. It's going to make things a lot easier. Okay. Yeah, if you just take a snapshot of this picture, you can just insert it in the homework. Take screenshots of the curve. So just, you know, take a picture of it and put it in your homework. That's all I'm asking. So if you want the probability that the z-score is greater than 2, that would be, you would then do above 2. And look at your picture. You don't have to clear those out, but above 2. So your z-score is 2, and the above 2 is shaded. So the probability that your data is above the z-score 2 is 0.0228, or 2.28%. There's only a 2.28% that your data lies above the z-score 2. So that's what this normal calculator tells us. And then we did talk about number 6. Well, there's 2 ways to do this. You could find the z-scores and just type them in this standard normal curve. For number 6, just find the z-score. But I like to do it this way. I just like to type in the mean. The mean's 1,000. The standard deviation's 94. And it says, what's probability the weekly demand is 960 boxes or less? So you would just, if it's 960 or less, you would want it below 960. Press calculate or just press enter. And notice 960 on your graph. 960 is right here. It's less than 1,000, so that makes sense. So this area is 0.3362. The whole area under a curve is 1. So all your answers have to be less than 1. Remember, it's probability. All the answers are less than 1. So it's 100% under the whole curve. This is 33.5%. Or 0.335 probability that the boxes are going to have less than 960. And the picture shows that. So that area is the probability, which is 0.3352 or 33.5%. So that's what you're finding. You're finding the probability that of any normal curve you can be found using this. Okay, so is that starting to make a little more sense? Okay, all right, awesome. So let me just one more thing, unless you have more questions. One more thing I want to look at is this calculator. So above would be to the right of the z-score. Below would be to the left. Okay, that's below left. Between would be between two z-scores or two values. And outside, so let's do outside just so you see it. Outside 200 and 1100. So that would be left and right. Let me make that bigger. Okay, so it would be outside 800, it would be left of 800, and outside of 1100 would be to the right of 1100. So we don't really use outside that much. We use above to the right, below to the left, or between. Oh, I thought a curve. Oh, I'm sorry. I think you're doing awesome. You're doing really good. So tonight I just tried to put everything together. No. Oh, well, I mean, yes, it's always good to be challenged. But remember, you can still call me or text me if you get stuck, okay? I'll be happy to look at it or look at your assignment before you turn it in. I'll be happy to do that too. Yes, I want to help people. I don't want people struggling. So if you're going to rewatch this video, we talked about number 7. Number 7 is a little different. So just make sure in number 7 you're going to use the central limit theorem. So you're going to use that calculator, the same calculator. But you're going to use, the mean is going to be the same. So just plug, what I mean is, here's the mean, just plug it in. But for the standard deviation, you're going to use the standard deviation divided by the square root of n, because we're dealing with example means. So I think you just came in when we were working this problem. So that's what I wanted to explain. But we worked it on the video. So if you don't understand it, again, just text me or call me. The only difference is instead of the standard deviation, you're going to use the standard deviation that they give you divided by the square root of n, where n is the number of things in the population, or sample size. But it's the same. And then in the calculator, you're just going to use between 42 and 50. Okay. Don't make it too hard. But I am recording this, so I will post it right after we finish. It takes a while to publish it, so I'll send out the link as soon as possible tonight. But I think that's all you need, unless you had anything else. Okay, good. Yeah, good. Always stop when you start getting confused like that, because you keep going back and forth. And what I've learned, when you learn math, the first thing that you think of, you always go back to. So the first thing you think of is usually the right thing. And, because your mind can go all different directions. And when that happens, just like shoot me a text or call me. Well, yeah, that's true too. It can't be that easy. I know. It's some things aren't gonna be that easy, but I'm trying to make it easy for you, more easy by explanations. But yeah, contact me with any questions. Okay. Well, like I said, I'm available, and I'll answer as soon as possible to help you. Okay, you're welcome. But I mean, I can stay if there was anything else um you might think that you have a question about. Is there anything that you might want to go over? Okay, that's a good idea. Um, and I'll be up for a while, so if you get stuck, give me a shout. All right. Well, you have a good night.